Good morning, everyone. Welcome to our last lesson of from the textbook. We will be having a couple more lessons next week that are not quite related to the textbook. Something that's more fun and spatial. If you get my drift. But let's get cracking. And first of all, check this out. Magnetic erasers. It's like, hey, they're probably not the strongest of magnets, but aren't they adorable? Look at this. It's awesome. All right. Anyway, on to math, guys. I think I found either the best or the worst angle for doing this. It's kind of like a first-person shooter, but like a first-person teacher. It's like you're in my eyes. All right, and this is from yesterday, so it's S sub n. Let me zoom out. We had S sub n equals. Now, let's see if you can remember how this looks. So, feel free to pause it if you want to. That's actually a really good strategy. So if you pause what I'm saying right now and just try to rewrite it, that's an excellent way of remembering what to do. In case you forgot, the way I like to remember it is the top has an a sub 1, and then in parentheses, there's a 1 minus r up top, 1 minus r at the bottom, except the numerator's 1 minus r has an n as an exponent for the base r. Okay, sweet. So now we're going to be talking about an infinite series. Okay, so before we talk about what that really means, let's show the formula. Now, if you know the geometric series formula for an infinite series, it's very similar. All you gotta do is remove this part, and that's it. Let's watch that again. This part. Okay, so for an infinite geometric series, we have S sub n, and by the way, n is always going to be infinity. So it's basically like you're adding up an infinite series of numbers, an infinite sequence. And you're probably wondering, well, isn't it always going to be infinity? It's like, well, no, not quite. There's certain geometric sequences that actually will have a numeric sum, and we will see those shortly. But this is the formula for an infinite series. All right, now let's see an example. Okay, welcome back. So let's talk about which of these problems require you to use the infinite geometric series formula versus the regular geometric series formula that we did yesterday. So in white up here, I rewrote the formula for the infinite geometric series, and let's look at some problems that will tell you which ones to use, which ones need to use the geometric series, the infinite geometric series. So we got, let's see. So if you look at, let's look at number, well, we got 37, 38, 40. Those you can just type into your calculator. However, they might not all work. And the way to tell if they're going to work is if the R value, whatever's in the parentheses, it has to be less than 1. So 37 is going to work. And the reason why is, if oops. If your R value is greater than 1, actually I should say if the absolute value of R is greater than 1. So basically if you have 1 and beyond, or less than 1, less than -1 and beyond, then you're going to have an exponential graph. If your R is greater than 1, you're going to have an exponential graph. If the absolute value of R is less than 1, then you're going to have it'll be an exponential decay. Okay? So only for these we can use infinite series. Because what happens as x gets larger and larger and larger and larger? Your y value becomes smaller and smaller and smaller and smaller and smaller. So you can actually find a sum of that, and that's actually a really cool thing that's to introduce you to calculus, is you can find the area and the sum of anything under these curves. And I think that's a really cool thing. So again, it won't work if the R value is greater than 1, so it's not going to work for that. But anytime your R value is less than 1, or its absolute value is less than 1, it'll work. So again, number 35. So 37 will work. 44 is going to work. 40 won't work because 1.0625 is larger than 1. So that's not going to work for the infinite series. Okay? And you honestly, all you have to do is just plug in the numbers into the formula. Let's see. So I'll do 27 with you guys. Okay? So 27, what is the R value? What's happening each time? So in number 27, what's happening is every time this goes up, whoops, can I draw? Sweet. Okay, so what happens every time I'm going up? I'm dividing by 2. So but we want to think of it in terms of multiplication. So I'm multiplying by 1/2, multiplying by 1/2. So we know for number 27, the R value is 1/2. And what was a sub 1? 4. So now just plug that into the formula. So plugging that into the formula, where a sub 1 was 4, R was 1/2. I'm going to change the color. Let's go with this. Okay, so using the infinite sum formula, where it's a sub 1 over 1 minus R, and we get 4 divided by 1/2, which 4 divided by 1/2 is 8. And that's how they got that. Okay. Now, if you want to use this on the calculator, if you want to just do this on the calculator, let me just show you something real quick. Don't do this. Don't do 4 divided by 1/2. Do not do that. That's going to give you the wrong answer. Here you're telling your calculator, take 4 divided by 1, which is 4, and then divide that answer by 2, which is 2. So if you want to do this in the calculator, it's going to have to be like this. See? And that's how you get 8. Now, if you want to do the infinite series, actually I lied. There is no infinity button on the TI-84s. So the TI Inspire, I believe, has it. The 89 has it. So you won't really be able to use this formula. You won't be able to do this summation thing on the calculator if you have an infinite series. But honestly, I mean, the formula is so straightforward and it's very easy. All you need are literally all you need are the R values and A sub 1 values. And you would have been done with it by the time I finish the sentence. So, no need for that, but that is it. That's all you have to do for infinite series. And that is the end of chapter 10, ladies and gentlemen.